Okay, let's start. They are joining in some time. Okay. Umayma Bachi, please turn on the camera. Yes. Should we start? Are all of you ready? Ramesh, Rishikesh, Bachi ready?
Yeah.
Fine. So I think in the last class, I just started with the idea of valency, right? I've not explained it completely.
Yeah.
Fine. So electronic configuration clear to everyone. Any problem in that? Did you all revise that?
Yes, ma'am.
Okay, fine. So yes, valence shell, valency, and valence electrons. Now let's quickly start with this idea here, which is valence shell, valency, valence electrons, and valency. What is valence shell? In the electronic configuration, which is separate and different from every other element, okay, we will have the last shell. We will have some last shell, okay, and that last shell we will get according to the filling of the electrons present in that atom. And how do we get the total number of electrons in an atom? How do we get the total number of
Atomic
electrons?
number.
Excellent. We get it through the atomic number because the number of protons, which is nothing but the atomic number, okay, will be equal to the number of electrons also, right? That's it. Good. We have arranged them in the electronic shell, we get the electronic configuration. Now, from that electronic configuration, whatever the last shell is there, that shell is called as the valence shell. That shell is called as the valence shell. Good. Now, second, there are some number of electrons present in the valence shell for each element. Those number of electrons are called as the valence electrons. Those electrons are called as the valence electrons. Now, come to the valency part, very important. Basically, every atom, every element wants to attain stability. Sorry, every element wants to attain stability. Okay, now when every element wants to attain stability, what is exactly stability for them? Stability for elements is nothing but the fully filled shells, fully filled valence shell. Okay, fully filled valence shell. And therefore what we see is that there are three elements in the first 20 elements which have their valence shell as fully filled, which have their valence shell as fully filled. And what are those three elements? Helium, neon, and argon. Helium, neon, and argon, right? Do they not have their valence shell as fully filled? For helium, what is the valence shell? For helium, what is the valence shell, bache?
1,
1. And what is the maximum capacity of the first shell?
2.
2.
2. And we see that helium has already 2 electrons filled in the valence shell, which is fully filled, right? Let's come to the next element with the fully filled valence shell. That is neon with the atomic number 10. What is the valence shell here? Which shell is the valence shell here?
2.
Second. We will not call it 2, we will call it the second shell, okay? And what are the valence electrons here? What are the number of valence electrons here?
8.
8. And is that the maximum capacity? Yes, that is equal to the maximum capacity. Therefore, for helium and neon both, the valence shells are already fully filled. Come on to the argon. Which is the valence shell here?
Third shell.
Third shell. What's the maximum capacity of the third shell?
8.
8. And we see that it is already having it completely fully filled, right? Therefore, these are three elements which already have a stability, right? Which already have the stability. So now come here. Next point, let's come to the next point. These three elements for the first 20 elements are called as inert gases. They are called as inert gases. Why are they called inert gases? Because since they already have the stability, they do not need to do anything. They do not need to do anything, right? They will not react with anything because they don't want anything else or they want to give anything. They already have their stability. Therefore, they are unreactive and therefore they are called as inert. Okay. They are unreactive and therefore they are called as inert, also noble, right? Or noble gases. Now, what is valency for other elements? They want to attain the electronic configuration as that of the nearest noble gas. Other elements, other elements, stability would be they want to acquire electronic configuration as that of nearest noble gas. This is very important. Why do they want to do this? Because these inert gases are already stable, right? So is it not that other elements want to gain stability? So therefore, in short, we are saying they want to become like the inert gases, which are already stable. Rishikesh,
Ma'am,
done?
no, ma'am, noble gases are inert gases, right?
Yep.
Yes, ma'am.
That's why I've written
Okay.
it there. So inert gases, noble gases, or also unreactive.
Done.
10 बच्चे? Okay. उमैमा 10 बच्चे?
Yes, ma'am.
Okay, Rami is done.
Yeah.
And for that, we get something this valency. Number of electrons lost or gained by by any element to attain electronic configuration as that of nearest noble gas. That's it. Done बच्चों?
Yeah.
Hmm. Ma'am, done? Fine.
Yes, ma'am.
Now let's quickly see it through the examples, okay? Please pay attention, all of you. We have helium, okay? Open up the NCRTs. We have helium on the second number. We have hydrogen on the first, right? We have lithium. We have beryllium. Next one is boron, carbon, nitrogen, oxygen, chlorine. Then 10th we have neon, okay? 10th we have neon. Let's see here. What is the electronic configuration for hydrogen? 1. What is for helium? 2. What is for lithium? 2 and 1. What is for beryllium? 2 and 2. Boron, 2 and 3. Carbon, 2 and 4. Nitrogen, 2 and 5. Oxygen, 2 and 6. Chlorine, 2 and 7. What is for neon? 2 and
8.
8.
8. Good. 8. Now let's see here. But please attention. Helium is an inert gas, we can see. And neon here is an inert gas, we can see that, right? Now let's see exactly what all other elements are going to do. All other elements are still not stable. They want to acquire stability, right? And what is stability? To have the last shell as fully filled, right? To have the last shell as fully filled. The elements underlined by green color here, that is helium and neon, they already have their valence shell as fully filled. Therefore, they are already stable. So other elements basically are trying to acquire the same thing. Now see, let's come to hydrogen first. Hydrogen has one electron in the first shell. Don't you think it will want to acquire the electronic configuration as that of neon here? Yes. Sorry, as that of helium here? Yes. As that of helium. And if it does that, what will it do? It will have to gain one more electron. It will gain one more electron in which shell? First shell or second shell?
Question.
First.
First shell. Good. And it becomes the electronic configuration like this. Now what we see is hydrogen and helium not same now. Their electronic configuration are same now, right?
Yes, ma'am.
They are same. And what has hydrogen basically done? It has gained one electron, therefore it has now attained the electronic configuration as that of
Helium.
helium. And why has it gained the electronic configuration as that of helium, Umema?
To become stable.
Umema?
Yes, ma'am.
Why has hydrogen gained the electronic configuration as that of helium, bache?
To exist independent.
Acha, to exist independently. Not really. Because when it is taking one electron, it is not really existing as independently, but rather to attain stability. Okay. Helium is stable, right? To fulfill the last shell, that's it. To fulfill the valence shell, right? That's it.
Yes, ma'am.
Now see, that's it. It has now 2 electrons. Let's come to lithium. Which one is lithium near to? So lithium is between helium and neon. Which one is it near to?
Helium.
Helium. So what will it do?
Lose an electron.
You will lose one electron.
It will lose one electron because helium has 2 electrons in the first shell. Lithium has 2 electrons in the first shell and 1 electron in the second shell. Therefore, it will lose 2 electrons. It will get an electronic configuration like this, which is now similar to that of helium, and that was the goal. Come to beryllium. What will beryllium do?
Lose 2.
Omama, will beryllium really lose 2 electrons?
Yeah.
Good. Why? Omama, why, bache?
To attain stability because it's.
Mm. See, good. Basically, beryllium is having 2 electrons in the first shell and 2 electrons in the second shell. Correct? It wants to attain that of electronic configuration as that of helium, which is just having 2 electrons in the first shell. Therefore, to become like that of helium, it will have to lose 2 electrons from which shell? Second shell. Okay, that's it. It becomes like this. Boron, what will it do, bacho?
Lose 3.
Lose 3 electrons, right?
And that's
Carbon,
and
it will be,
which one is that atom? Fifth one?
sorry,
Which one is the fifth one? Boron.
not able to understand, sorry.
The fifth one is boron.
Yes, fifth one is boron. B represents boron. Carbon, what will it do? If you see very clearly that it is also in between, like it is also near to in equal distance with helium and with neon, right? So it might attain for both. Basically, what happens, carbon neither loses 4 electrons, neither gains 4 electrons. It really shares the electrons. Okay, so we will see the case of carbon later because it is not gaining or losing the electrons as that. Okay, come to nitrogen. Haji, clearly it is near to Rishikesh. Is nitrogen near to helium or neon?
Neon.
Neon. So what will it do, Mohammed?
Well, ma'am.
What will nitrogen do?
Lose 8.
Okay, 5.
Yes, ma'am.
Rishikesh,
Yes, ma'am.
what will nitrogen do? Will it lose 5 electrons?
No, ma'am. It will try to gain electron.
Good. See, this nitrogen is not near to helium. Rather, it is nearer to neon, right?
Yes,
It will
ma'am.
want to
So it will
attain the
gain 3
electronic
electrons.
configuration as that of helium. Now just see that compare the electronic configurations of nitrogen and neon, right? Nitrogen and neon. Nitrogen is 2 electrons in the first shell, 5 in the second shell, right? Neon is also 2 electrons in the first shell, which is same for nitrogen. It has 8 electrons in the second shell. Don't you think 5 nitrogens, 5 will want to become 8? Nitrogens having 5 electrons in the second shell, it will want to have how many electrons in the second shell now?
8.
8.
Oh, 8. Umama, will it want to have 8, bache?
Yes, ma'am.
Yes. So for that, what will it have to do? It will have to gain 3 electrons, right? And now the electronic configuration becomes this, which is similar to that of neon, right? which is similar to that of neon. For oxygen, what will happen, Umama?
It will gain 2 electrons.
Excellent. For fluorine, Ali?
For fluorine, it will be. I don't know.
1 electron, right? It will become like this. It is already 7. It wants to have 8. So it will just gain 1, right? For neon, it is already inert. Therefore, it will not want to do anything. Is this understood to everyone?
Yeah.
No, we said
Yes.
chlorine, right?
Fluorine. 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 Okay. Now let's come to the next part.
Oh, I heard chlorine, not
So,
fluorine.
but chlorine will also gain 1 electron, huh? Now see. The next one, what is the 11th one? Sodium. 12th is magnesium. 13th, aluminium. 14th, silicon. 15th, phosphorus. 16th, sulfur. 17th, chlorine. 18th, argon. Okay, let's do for these 8 now. Ma'am, are you writing? But should I wait? Okay, fine. So sodium is near to which one? Argon or neon?
Neon.
Neon. What will it want to do? Will it want to attain the electronic configuration as that of
Neon.
neon? What will it do for that?
Lose 1 electron.
Lose 1 electron. Excellent. What is the electronic configuration now? 2 and 8, which is
8.
like that of neon. Therefore, it has gained stability. Magnesium, how many electrons will it lose? 2
2.
electrons, right? So 2 and 8. Aluminium, lose 3 electrons. 2 and 8. Silicon, again the same case like that of carbon. So we will deal it later. Phosphorus, what will it do? Now, is it closer to neon or is it closer to argon?
Argon.
What will it do?
It will gain.
Acha, tell me the electronic configuration of phosphorus. All of you.
2, 8, 5.
Excellent. What's the electronic configuration of argon?
2, 8, 8.
2, 8, 8. 2 in both the first shell, both of them are having 2. That's fine. Both of them are having 8 in the second shell also. Fine. Come to the third shell. Phosphorus is having 5 in the third shell. Whereas argon is having 8 electrons in the third shell. What will phosphorus want to do? It will want to have 8 electrons in which shell? The third shell, right? So it will want 3 more electrons to have 5 to have the 5 electrons change into 8 electrons. Yes. So what will it do? Umama, how many electrons will it gain?
3.
3. So it becomes like this, right? Come to the sulfur. What will it do, bacha?
Gain 2 electrons.
Excellent. Ali, what will chlorine do?
It will gain.
How many? Tell me the electronic configuration of chlorine, Ali.
Electronic of.
You are mute.
Electronic configuration.
Again mute. Electronic configuration of chlorine.
What was it? Oh,
What's the atomic
287.
number? Okay. So what will it want to do? It has how
It
many
will
valence
gain
electrons?
one cell.
One
One
cell.
electron.
Huh.
One electron cell.
How many valence electrons does it have? Chlorine.
Valence electrons. 7.
Good. How many valence electrons are there in argon?
8.
8. So it will gain 1 electron and therefore it will have the electronic configuration case. Come to the next two. That is, which is 19th? Potassium. Which is 20th? Calcium. Okay. What's the electronic configuration of potassium?
It
2,
will lose 1
8,
2,
electron.
8, 8,
and
1.
1. What's for calcium? 2, 8, 8, 2.
Ma'am,
Again, they both are very close to argon. Yes. Who is that?
why don't we learn
Rem-
it as 2, 8, 9 and 2, 8, 11? Because the maximum number of electrons in the third shell is 18, right?
That is for the elements which are like, above with atomic number above 20, because that is the transition metal. And then we have the D subshell also. So till here we are just having the S and the P subshells. From the elements with the atomic number 21, we have the D subshell. Therefore, for those elements, we can say that the maximum capacity for the third shell will be 18. But till 20 elements, with the atomic number till 28, okay, elements are not really having the D subshell. Therefore, the maximum capacity will be 8 only. This is not for your syllabus, but there's no other explanation for this. Okay, just imagine that there is no room for those 10 electrons here. Once we are into the 21st element, okay, from then onwards we have different rooms for the 10 electrons. But till 20 elements, we do not have rooms. So therefore, we'll be adjusting them like this only. Rishikesh is somewhat understood?
Yes,
Okay. So they're clearly nearer to argon. So what will they want to acquire? They will want to acquire the electronic configuration as that of argon. So what will they do, Ramesh? What will potassium do?
Lose 1 electron.
For calcium, what will it do?
Lose 2 electrons.
2 electrons. Clear? It becomes this, and it also becomes this. Anyone any problem here?
Um,
No.
No, ma'am.
What is the 15th element?
15th is phosphorus.
Okay.
15th is phosphorus. Umama is writing, so let's just wait for a minute and then we'll come to the next point. Write it, write it. Why have Rishikesh, Ali, and Ramesh not given the test?
ma'am, I had exams last week, so that week I didn't give a test.
Ali, what is your point?
Ma'am, I didn't write the previous 2 tests because I had chemistry in the previous 2 tests because there was no exam. Science exam actually.
Ramesh, what is your point?
I think I went out.
Try to write the test. Yes, done, Umama? Umama, wait after the class, okay? All others will leave. I want to discuss your test paper with you. Okay, remind me for that. Fine. Now come here. Let's take the example for sodium, okay? Please pay attention. Sodium, the electronic configuration is this. What does it do? It loses 1 electron, correct?
Yeah.
And it becomes 2 and 8. So what is the valency here? What is the valency here?
1.
1. Why is valency 1 here?
Because it loses 1 electron to gain
It is losing
stability.
1 electron to fulfill the last shell, right? Good.
Yeah.
Now you see here, why is valency also called as the combining capacity? Because if sodium wants to give 1 electron, right? That is its capacity by which it can combine. Let's suppose Umama also needs 1 electron, right? So it can definitely combine very easily in a ratio 1:1 with sodium, because sodium also wants to give 1 electron and Umama also wants to take 1 electron, right? Correct? If sodium is giving 1 electron and Ali wants 2 electrons, so sodium will have to be 2 in number, so that each sodium atom is giving in total of 2 electrons because Ali wants 2, right? Why? Because the combining capacity, that is the valency of sodium, is 1. Yes or no?
Yeah.
That is the same thing that we
Yes.
were learning while we were learning the chemical formulas, how to make the chemical formulas, okay? Now see one very, very, very important point here. First case, we have sodium atom. We have the sodium atom, which has 11 protons and 11 electrons, correct? Then we have the sodium ion, and which has 11 protons, because protons are neither added nor lost, not gained, okay? And now the sodium atom has lost how many electrons?
1 electron.
So it will now have 10 electrons, right? Now,
Yeah.
if you see here, 10 electrons, in the first case, 11 electrons are neutralizing the 11 protons. Therefore, there is neutral charge on the sodium atom. There is neutral charge on the sodium atom. But in the second case, if you see, 10 electrons will be able to neutralize only 10 protons. 1 proton's charge will still be left unneutralized. Yes or no? Yes or no,
Ma'am,
bachcho?
can you repeat?
Yes.
Yes. In the first case, bache, see, in the first case, there are 11 electrons in the atom. Also, there are 11 protons in the atom, right? Everyone agrees with that?
Yeah.
So 11 electrons are neutralizing 11 protons. The charge is being neutralized, right? Because
Yeah.
both of them have equal charge and opposite and equal charges. Therefore, they are neutralized. Now, therefore, in the first case, the atom is overall neutral, right?
Yeah.
That's
Correct?
fine.
Everyone agrees with that? Fine. Omega, fine, bache? Fine.
Yes, ma'am.
Sorry. Come to the second case, you see. In the second case, sodium atom has 11 protons, but it has 10 electrons. Why does it have 10 electrons? Because it lost one electron to gain stability, right? It lost one electron. Now it has 10 electrons. So these 10 electrons will be able to neutralize the effect of 10 protons, right?
Yeah.
Correct?
Mm.
And one proton's charge is still left unneutralized, right? So don't
Yeah.
you think it will not be neutral overall, but rather it will be positive?
Yeah.
Yes, ma'am.
Yep. Umema, I think there is some confusion.
No, ma'am.
Okay. There will be some charge here. And what will be that charge? That will be positive charge. Why is there positive charge? Because an extra positive charge is there, right? Negative charge is less. Positive charge is more. Definitely, which will be the dominant one? The positive charge, right? And you see how many protons are not neutralized? How many protons are not neutralized?
1.
1. So what will be the charge overall? Can I say plus 1 charge?
Yeah.
That's fine.
Rishikesh, Ali and Patna, understood, bache?
Yes.
Umema, feel free to ask any question, any doubt. Do not hesitate. Therefore, it was the sodium atom and now it has become the sodium ion. Why ion? Because it has attained a charge. You see that? It has attained a charge and a charge of how much? Plus 1. Why plus 1? Because plus 1 is the, 1 is the valency. Okay. 1 is the valency. So here at times you will also see valency written as plus 1. Why plus 1? Because 1 is indicating how many electrons are lost. Okay. How many electrons are lost? And what is plus indicating? Whether electron is gained or lost. You see, there will be a positive charge whenever electrons are lost. Always note it. Positive charge. Electrons lost. That's it. Right? You see here that this indicates one electron has been lost. How do you know it has been lost? Because the charge is positive or negative?
It's positive.
Positive. Positive means what? Proton is more. Why can the proton be more? It definitely no more proton has been added. The number of electrons has been reduced, right?
Yes, ma'am.
But you respond, Rishikesh, Ramesh, Ali.
Yeah.
That's fine.
Is it even
Yes, ma'am.
understood?
Yes.
Clear? Fine. Now let's see the second case for oxygen. Okay. For oxygen, sorry. In the first case, bache, it has 8 protons. And how many electrons? 8 electrons, right? In the second case, this has 8 protons, but it has gained 2 electrons. Yes or no? The valency is 2. Please check it.
Yes, ma'am.
Right? So now it has 8 electrons. In the first case, bache, 8 electrons and 8 protons neutralize each other. We get neutral atom, right?
Yes, ma'am.
Fine.
In the second case, 8 protons will be able to neutralize just 8 electrons. 2 electrons will still be left unneutralized, right?
So it will be positive.
-2. Which charge is dominant, negative or positive? Which charge is
Negative.
left unneutralized? Negative, right? How many times? 2 electrons are left unneutralized, right? So the charge will be? The charge will be
-2.
Negative.
-2. Do you agree? All of you understand this?
Yes.
And if you see here
Yes,
one thing,
ma'am.
oxygen's valency is also 2. 2. We write -2 just to indicate whether electrons are, gained or lost. Minus indicates what?
Using gain electron.
Yes, negative charge means negative charge means electrons are gained. Anyone, bachcho, any problem? Please tell me.
No, ma'am.
No.
No, ma'am.
Is it understood clearly?
I understood.
Yes,
Ma'am.
ma'am.
Yes,
Umaima,
ma'am.
bachcha understood?
Yes, ma'am.
Good. Now you see here, bachcha, one thing which is very important to be noted. Let's suppose this is the atom which is earlier neutral, which is neutral atom. When it is changing into the ion, whether cation or anion, is proton really a concern here? Is proton really doing anything?
No.
No. What is it that is actually changing or doing something?
Electrons.
Electron. In cations, electrons are what? Lost. Electrons are lost. In anions, electrons are
Gained.
Gain.
gained. That's it. Therefore, in an atom, it is the electrons which show the movement. It is the electron which is participating in the chemical reaction. It is the electron which is leading to the chemical reaction. Transfer of electron or the sharing of electron is the thing which is actually causing the chemical reactions to take place. The simplest part is this. Okay? That's it. It is the
Yes,
electron.
ma'am.
Protons will be untouched, they will be as it is. Which is in the outer shells? Which is in the outer part of the atom? Proton or electron?
Electrons.
Electron. Which subatomic particle will show the movement? Electron, right? Which has to be fully filled? Electrons, right? They will have to be fully filled according to the valence shell. So either they'll be lost or they'll be gained. But it is the electron which is basically showing the movement. Rishikesh, Umaima, Ali, and Ramesh. Clear?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Fine.
Yes, ma'am.
Let's practice some questions, okay? So the element with atomic number 12 and the element with atomic number 16. Okay, let's see how do they react. Okay, let's see that. So this is the basic point from which we'll be covering every concept till now that we have studied. Okay, see here, atomic number is 12. Therefore, what will be the number of electrons? So are we really bothered with the numbers and the arrangement of protons, or are we just bothered with the electrons? What is really participating in the chemical reaction?
Electrons.
Electrons, right? So we'll straight away come to the number of electrons and therefore the electronic configuration, right? So the number of electrons are how many?
12.
12.
12. Umaima, for 16, atomic number 16, number of electrons is
16.
good. Electronic configuration for atomic number with 12,
282.
282. For 16, what is the atomic configuration? Bache?
286.
284.
Good.
Sorry, 286. Sorry.
No worries. 286. Okay, fine. Now you see here, definitely it will be losing 2 electrons. Magnesium, this is magnesium, okay? So don't you think here magnesium will have a valency like +2? Yes or no?
Yes, ma'am.
And
Yes.
here this is sulfur, okay? Sulfur will have a charge of -2. Please see, now it should be very clear why do we get the valency as +2 and why do we get the valency as -2. Clear? See,
Yes, ma'am.
sulfur will be gaining 2 electrons to have it 8, therefore minus charge. And how many electrons are being gained?
2.
2.
2. For magnesium, how many electrons are lost?
2.
What can we do now? Can we crisscross them to know the chemical formula? This is how they are reacting. Why are they reacting like this?
NGS.
Because that is their combining capacities. That is their valency. That is their combining capacities. The number of electrons lost or gained. What is the formula we get here? Mg2h
NGS.
like this or Mgs? Which one is correct?
NGS. Because the negative 2 and
Excellent.
positive cancel it out.
Yeah.
Yes, ma'am. MG.
Yes. Okay. That's it. Please tell me any problem here.
No.
No, ma'am.
No,
No,
ma'am.
ma'am.
And if you see very carefully, why is valency referred to as the combining capacity? Because it is the electrons movement basically which is causing the reaction, right? Which is ultimately causing the chemical reaction or the chemical bonds to take place. Now you see, how many electrons can you give or take is nothing but the valency, right? and based on that we are having the reaction. Therefore, the valency is called as the combining capacity or the combining power of the element. Clear? Now, quickly, all of you, do it on your own. Tell me the chemical formula when element with atomic number 4 reacts with element with atomic number 17. Quickly, with each and every detail and step that we have done right now. All of you, quickly. I want the chemical formula for these two elements when they are reacted together. And don't do it here, do it on the copy. Ali, are you doing?
And we put it in the chat.
Sorry?
Put it in the chat. We put the
Bachchan?
answer in the chat.
Yeah, you can. I can see it here. हाँ जी बच्चों डन. अच्छा do.
Ma'am, is my answer correct?
I'm seeing it, just 1 second. Rishikesh is fine. Ramesh is also fine. Excellent. So now, have you understood the concept? How do we get the valencies? For the first 20 elements, at least there is no need to just mug up the valency. You know the concept. But you should know them by heart because obviously you will not solve the valency of each and element then. Okay? But you should know. In case you forget, you know the method. Am I done?
Yes,
Am I
ma'am.
Okay, what's your answer, bache?
I got PeCl2.
Excellent. Excellent. Ali, is that the same answer that you have gotten? Ali,
I
I
got
think it's
BE2Cl. No, 2BeCl.
2 BeCl.
No.
Okay, let's
I
see.
got
Let's see. Okay, no worries. Let's see. Okay. So Z is equal to 4 means how many electrons? 4 electrons, right? What will be the electronic configuration? 2 in the first shell, 2 in the second shell, right? Now for Z is equal to 17 means how many electrons? 17 electrons, right? What will be the
2,
electronic
8, and
configuration?
7.
2 and 7, right? 2, 8, and 7. Good. Now here, what will be the valency? It will definitely lose 2 electrons. It will definitely
Yes,
lose
ma'am.
2 electrons. So therefore, the valency becomes 2. Here, what will be the valency?
1.
It will definitely gain 1 electron. So what the valency becomes? -1. Okay. Now that's it. How do we know the chemical formula? We write the symbols. What is the element with atomic number 4? That is beryllium. What is the atomic number with 17? That is chlorine. Okay. We write their respective valencies. That is +2 and -1. Okay. We crisscross them. We get BeCl2. Now what will be the name of this compound?
Beryllium chloride.
Why chloride? My question is this. Rishikesh, Ramesh, बच्चे, why chloride?
Because there is one chlorine atom.
So why chloride? Why not chlorine?
Because that's how we learned it.
That's how?
We learned it like that.
Acha. Who told you this?
Me.
I have explained you this concept in detail in the third chapter.
Ma'am, is
In
it because
detail.
chlorine has two?
If I make it 3, then will it change? Or if I make it 1, will it remain same? Will it remain chlorine? No. It will still be chloride.
Because it's a
It is
non-metal.
Ma'am, because sulfate,
it's
sulfide, and
just a
sulfite
second.
change because of
Umaima,
the.
just one second. Umaima, what's the answer?
Because it's a non-metal.
Excellent. Basically, the point that Umaima is saying is this. I've told you this 1000 times that when an atom gains a positive charge, that is when it becomes a cation. Its name is same as was for the atom. When an atom becomes an anion, that is when it gains a negative charge, its name changes. Okay.
Ma'am, so we can
Now
say
here,
that
just one
chloride is
second.
like
Just
negatively.
just one second. Here it is the beryllium ion. We will simply write beryllium ion. It was the beryllium atom. After losing 2 electrons, it becomes the ion. But the name will still be beryllium ion. Okay. It was chlorine atom, but after gaining 1 electron with a valency of -1, it becomes chloride ion. Huh? In the compound, what are the two parts that are combining? Beryllium ion and the chloride ion. What we will get? Beryllium chloride. Is it understood by everyone?
Yeah.
Ali, speak up your question.
No, this was my doubt. That
Okay.
if we had negative
Ma'am,
ions, so it will be negative.
Yes. Yes.
ma'am, so if
Huh.
chlorine was positive, we would have beryllium chlorine.
But we will never have chlorine as positive. Can we really have chlorine as positive?
Or
Will it
no?
lose 7 electrons?
No.
Never. Will it gain 1 electron? Yes. Okay. That is on the electronic configuration. Fine. Good. Now, next, last one question, bache. Atomic number 19 and atomic number 8. Quickly, the name, the compound, the valency, everything, the electronic configuration, everything, all of you.
Ma'am, can you
The
give a
formula.
hint?
No. We have discussed everything in detail, bache. What is the need for a hint?
For the formula, I was trying to guess.
Why guess? Solve it. Solve it. Inshallah, in the next class, we'll be learning isotopes and isobars, although I've discussed them somewhat. Mama, bache, remove this animation.
Mom, it
Although
was
we
my
are
brother.
okay, fine, no worries, no worry. Um, yes, although we have discussed isotopes and isobars somewhat, we'll just have a revised part there and we'll deal with the examples. That's it. Inshallah, in the next class.
Ma'am, can you check my answer?
Yes, just one second. K2O, okay, excellent. Both of you. While I'm solving the question here, no one will answer except Ali.
Okay, ma'am.
Umaima, once you are done with it, let me know. So Ali, how did the exams go? You had your science exam. How did the exam go?
Done.
It went very well.
Then out well. Yes, or ma'am. What's the answer?
I got K2O.
Excellent. Excellent. See, let's see. Haji, Ali, what Z is equal to 19? What are the number of electrons? No one else will answer.
2, 8, 8, and 1.
Did not answer electronic configuration, but anyhow, fine. So 2, 8, 8, and 1, right?
Um,
For Z is equal to 8, the electronic configuration is?
2 and 6.
What is the valency? For Z is equal to 19.
I got -1.
For
And
Z
then
is
for
equal to
oxygen,
8,
2, +2.
positive 2. Ajay, tell me, why are you getting negative for 19?
And because it needs to lose one cell. Lose one like
And
electron.
whenever electrons are lost, the number of protons will increase. What charge will be more? The positive charge. Whenever electrons are lost, positive charge is attained, and it will be +1. Whenever electrons are gained, number of electrons will increase, therefore the negative charge is there. And whenever electrons are lost, negative charge is there. Now, how do we know the formula? What are the symbols? What's the element with the atomic number 19?
Potassium now.
Okay, what's the element with atomic number 8?
Oxygen.
+1, -2. Should I crisscross them?
Yes, ma'am, we'll get K2O.
A2. What's the name of this compound? Tell me the correct name.
Potassium oxide,
Potassium oxide. Why oxide?
because it's a non-metal.
Right now you will tell me because it's a negative ion. It's an anion. Okay, its name will change. Rishikesh, tell me one thing. What are the elements found in this compound potassium oxide? Elements.
Potassium and oxygen.
What are the ions found in this compound? Constituting this compound? Ions.
Oxide.
And
Potassium.
potassium ion and oxide ion. Be clear with the difference. Elements are still potassium and oxygen. The ions are potassium ion and the oxide ion. Okay, that's it. So I hope everyone is clear with this part. I just want to
Yeah.
discuss two things here. Please, I'll take 2 to 3 minutes more. Just 1 second. Is everyone clear with this concept? So let's suppose I
Yes,
want to
ma'am.
draw the electronic configuration for the oxygen. So what will I do? 2 electrons in the first shell. And how many electrons in the second shell? 6,
Yeah.
right? That's it. So through this also the questions could be asked, but I hope you know this concept well. That's it. Now one last point I want to get that corrected. I think I told you the proton mass of proton as 1.6 something something into 10 raised to the power minus 27 kg, right? While we discuss the mass of electron as 9.11 into something something into 10 raised to the power minus 31 kg, correct? Whereas mass of proton and neutron, they are almost similar. And while we were comparing it, I just took these values and through this we get it around 10,000 times higher in mass, right? That's not the correct thing. The point is we also have to take the full value, that is this and this. And when we compare these two values along with their notations, we get it mass of proton is approximately 1,836 times heavier than mass of
Electrons.
electron. That's it. Okay. So please correct this. The mass of proton. The proton basically is 1,836 times higher, heavier than the mass of electron or the electron. Okay. Please correct this. This could be asked in the objective form question. Fine. By looking at the orbit diagram, these are called as the orbital diagrams, the shells, okay, drawing like this, you can easily tell the valency.
Yes, ma'am.
Inshallah, in the next class, we'll start with the isotopes and isobars. But please revise.
Done, ma'am.
There's one question in NCRT. There's one question in NCRT which is this. Atomic number of an element is 8. I'll change this question just 1 second. Atomic number of an element is 13 and the mass number of an element is 27. Okay. Tell the number of electrons, protons, neutrons and charge on the atom. Quickly, in a
What
minute.
was 27?
The mass number, it is as A, okay? The mass number. I hope you know what is mass number now. Quickly in a minute, all of you.
I have to
I'm
find
giving
number
all of you 1 minute.
No, I have to find number of
Electron, proton, neutron,
and the charge.
and the charge on the atom. Yeah.
Okay.
Ma'am, in chat.
Huh? Yeah, tell me in the charts. I can see your answer just 1 second. हाँ जी बच्चों.
Ma'am, can you check my answer?
Yes, have you shared it? Just 1 second.
Yes, ma'am.
Okay. Excellent. Also remind me in the next class to discuss the case for carbon and silicon. I wanted to discuss it today, but then there's no time now. You remind it, okay? हाँ जी, Ali, Umaima, Rami is done, बच्चे.
Yeah.
Ali, just tell me the charge.
No, ma'am.
The
Charge
charge.
will be neutral.
That's right. Okay. For an atom having equal number of electrons and protons will be neutral. But the question is trying to ask that what is the charge it can attain. Okay, that is what the question is trying to ask. Okay, bache? When the atomic number is 13, based on this atomic number, what number of electrons will be there? What's the electron here? Number of electrons?
13.
Proton,
13.
13.
neutrons, 14, right? Mama,
14.
what is the charge that we have got? Have you also
I
gotten
did not-
neutral?
No, I did not do it.
Okay, why, bache? See, look here, the electronic configuration will be what? 2, 8, and 3, right? Because it's 13. So what will it do? It will lose 3 electrons. It will lose 3 electrons. It will attain a charge of +3. That's it. Okay. Ali and Umama understood? Ramesh and Rishikesh, bache, you may leave. Thank you. The
Bye.
next class. will be. Bye.
Sorry.
Ramesh. Okay, has he left it? Okay. Okay, fine. Haji. Ali, is it understood or not?
Yes, sir, it's understood.
Fine. You may also leave. Thank you.
Thank you.
Ma'am, understood?
Yes, ma'am.
Why did you not do this one?
Oh, ma'am, I was confused.
in
Like how to solve, how to find it.
Is it clear now? You
Yes,
just
ma'am.
have to follow 3 steps. Know the atomic number, know the number of protons and electrons, and